Yeah, hello. My name is Michael. I'm coming from a small company from Germany. I wanted to come here for the StopOn and OpenNebula Tech Day. Also to talk about to Boyan and Boyan about the new StopOn features coming out in the near future. And he was clever, asking me immediately, "Hey, perfect! When you're here, can you give some words about your setup, about your Nebula installation and StopOn integration into Nebula, etc." He said half an hour. Okay. Yeah, I said yes, and want to share with you some experiences we made with OpenNebula, and since last year also with StopOn. And to start with it, I give you some words about me and the company we are running. So my name, Michael Kutzner, I'm 48 and I own a small hosting company in Germany. When I say small, it's really small. We are currently 6 people, providing on the one hand hosting services, but on the other hand also consulting, infrastructure consulting and management services. When I say 6 people, a lot of you will ask yourself, how can they drive servers in a data center with that amount of people? Yeah, because we are using StopOn and OpenNebula. No, we focus in the past a lot on automation, a lot on redundancies, so that there is not so much to manage from the infrastructure side. So that brings me to the next. When I say we don't focus on the infrastructure for us, a server, a disk, a virtual machine is just a driver for what we provide to our customers. So we are focusing on managing the applications from the customers. So we are using infrastructure just as a vehicle to provide services to our customers. To give an example, we have customers running their platform with us, and they never touch any server. We manage everything on their platform, on software developed by their own developers on our servers. So we take care about that, not about the infrastructure. We started doing that in 2011. Now 6 years we are online. We started from the beginning with OpenNebula, or let's say a few months after we installed OpenNebula the first time. We are running customers who are storing a lot of data, who are running archive services, who are running banking services that required us to do some ISO certification, where we have been the first company with only 4 people in Germany, I think, doing that. And everybody said, "Are you crazy?" Because it just creates a lot of work and brings you nothing. I'm happy that we have done it. So, what are we doing? I said we started in 2011. We currently have 3 data center locations. In 2 data centers. So one data centers where we have our racks in are divided in 2 different fire zones. That means if a part of the data center goes down, the services still run because we have everything redundant inside, with some limitations regarding StopOn that I will talk later about. And we have a third location which is around 130, 150 kilometers away, where we are interconnected via dark fiber, where we store offsite backups, where we have certain replication of databases working, because we have customers which are very sensitive to that, which require us to, each time even if an atomic bomb on the data center is going down, they need their data. What is special on our usage of OpenNebula? You have seen in the morning, in the hands-on session, how it is used. So you have a template, you have an image, and you create a lot of volatile virtual machines out of that single template and that single image. We are doing something crazy because we sometimes, or a lot of times, have a one-to-one relation between a template and a server. Why that? Because we are not only using volatile machines, but a lot of static machines. So like you do classically in a VMware environment, for example. Why do we do that? The servers we are running are in 80% of the cases handmade. So a database which has special setup required, special application server setups, etc. And we are using Nebula not only for managing the machine, firing them up and taking them down. What we sometimes also do, especially in redundant environments, take down a machine, undeploy a machine, which copies back the image, which is on the hardware node, to the image repository. So we have a clean backup, which we are using for disaster recovery reasons. It's easier, for example, to fire up a Windows machine from 2 weeks ago and recover a certain part out of the backup than do a complete disaster recover backup or recovery out of a backup. So it makes it easier to us to work with backup and recovery. That's why we have this one-to-one relation between templates and servers. Then we also have classical volatile machines in certain environments. So where, for example, we use the formation services, firing up a new application server if the load goes up and taking it down again when the load goes down. Other things we have done is we have our own small customer portal where we have extended the services or extended information about servers, which we are integrating via the API OpenNebula provides, for example, for patch management. As I said, we have non-volatile machines, means we need to update machines, install security fixes, and so on. I will show it later. So, and then we are running at customer side also certain servers which are not running in our data centers. So, how do customers use the OpenNebula installation at us? I think that is something of interest. So, classic usage: Sunstone self-service. We have customers accessing Sunstone and are managing their own machines. So they are in 90% of the cases, they are just watching at the machines. They just want to know what is running. Is it running fine? How many servers are running? Is everything up and running? So when it comes to increase the number of servers, they call us. So that is the OpenNebula use. Integrations, I said, we have a self-service portal which is using OpenNebula as source for all the servers. So I said patch management. What does it mean for us? As I said, we have a lot of manually fine-made machines for the customers. So we need to patch them. Let's say a new kernel needs to be installed, Windows updates needs to be installed, and so on. What does it mean? It's a lot of manual work. We have to agree with each customer, when can we do it? What is the perfect time for that? Which has been done? So which server was patched? But also are there, because when the people are doing it in the morning, they don't know every server in detail. So that are, let's say, 500 servers which are running. They don't know every server and what needs to be taken into account when you are taking it down, when you are rebooting it. Perhaps a database is running on that. That means on other servers you have to put a maintenance mode, for example. That is something we are storing in a separate database in our customers portal. And so the administrators can go down server by server and check what needs to be done when we are putting the hands on the machines. Then we have API integrations for special environments where a machine starts up and needs to get some information about itself. That's where we are using also the OpenNebula integration and APIs, which is perfect for the use cases. So, and all the other things you have seen in the morning, the flow-based services to automatically manage complete environments. What are we using down under? When we started in 2011 with Nebula, for us there was one rule which was a kind of shared nothing infrastructure. So means that 2 fire zones. We cannot share storage from one fire zone to the other one, because what would that mean? If one part of the data center goes down, the second part is also down. That brings nothing. So we used shared nothing environments at the beginning. So every server was using local RAID storage. There was only one driver at that time supported by Nebula. That was the SSH driver, which copies the images from the repository to the server. That was fine at the beginning when we only had a 1 gigabit network. A few years ago we started pushing everything to 10 gigabit. And then we run into performance issues because SSH cannot saturate a 10 gigabit network anymore. At the beginning, we made the repository available via NFS to each server, modified the SSH drivers, and copied the images directly via NFS to these servers. What is the disadvantage? If you have a central storage somewhere here and you have it available on all your machines and a hacker gets out of a virtual machine, last year I think we had 3 possible issues in KVM, where you could break out of the virtual machine. So he goes to the image repository, does an RM minus RF, and he's done, and he has fucked us. So not nice. So we started using again SSH, but a special version, which are patches which are added to SSH, creating the possibility to only make the authentication in an encrypted way and do the transport of the pure data, so of the images when they are copied from the repository, from the front end, to the server, to the local server. The data is not encrypted anymore, which boosts the performance. So with classical SSH, we then get around 300, 400, 500 megabyte per second transfer bandwidth. That was not enough because the demand has grown for 2 things to our storage environment. First, performance, easy. Just put SSDs in every server and you are done. I thought about it at the beginning. It was the easiest way. The next demand was, we have a server, the newest servers, to give you an example, that are servers equipped with SSDs, so they provide between 6 and 10 terabyte of local SSD space for local usage, have around half a terabyte of RAM, and between 48 and whatever cores. but there were users which had the demand for more storage. So when we have on such a server running 50, 60, 70 VMs, what does it mean? Each VM takes around 100 gigabyte of space. And then comes the next VM that is a database which needs 2 terabyte of disk space. And it's full. So we looked around what is able and capable of delivering an increasing size in a volume and what is able to delivering the IOPS. And at that time we found StopOn. And I think I've sent you an email at that time. Can we do a test installation? And 2 weeks after, we had the first StopOn cluster up and running. And I was impressed from the performance as well as the easiness of use. How it can be used on the servers themselves, so configuration, installation, etc. But also the integration into OpenNebula, which is really vital to us. Because in day-to-day work, we are exclusively relying on OpenNebula to manage the virtual machines. Now also the storage. So practically, we are now using all the servers in a converged way. Means we are using classical VLAN networking, which is able to deliver the performance we need in a 10 gigabit network. We are using libvirt plus KVM. KVM is not the standard one of the distribution. We do it on our own, compile it in our own, and use the options when compiling it. Then we have local RAID systems in each server, which are heavily used, for example, in distributed systems. For example, if you have anybody of you has ever set up an Elasticsearch cluster, which is distributed about multiple nodes and uses local storage because it takes care of its own data distribution. So that is stored here on the local RAID systems. Then we have databases running. I think the biggest database is a Microsoft SQL server with around in use 3.5 or 4 terabyte of disk with really high I/O demand. So we run into a problem. I said to the customer, hey, "What's going on? Yeah, there's a table with 800 million entries." I said, "What? I don't know. 800 million, and if you have ever seen such a database." And then they had queries which made a full table scan on that 800 million entries, rows. So we were sitting there in a video conference and asking ourselves, does it make sense? What can we do? The issue was with StopOn, we did not run into performance issues, so nobody took care. After that, they optimized a little bit, and they archived also away, I think, 95% of the data. Oh, we don't need all this. We need around 1 or 2 million entries. Yeah, perhaps we can delete the other 798 million entries. Okay, so that's a classical setup we are doing. I think I've said most of the words. That StopOn implementation, we started last year. I think we were the first customer asking you to come here and to do the installation together, because StopOn normally installs the software on the server remotely and does the management. That is something we could not do because we have an ISO certification and we cannot leave anybody from remote touching our service. So we have to do it on our own. That was really cool coming here and working with Bojan, Anton, and everybody installing the system, tuning the system on productive servers. So there were customers running on that servers. We could not. Oh, we can't. We have to reboot the server. No, it's not possible. We can't. So it was really working on the open heart and installing StopOn to get it live, and was very impressive what a good time it was here. So we went productive 3 months later. We made first tests, checked the performance and so on. How is the setup? We have 2 clusters currently running. In each fire zone we have 1 cluster. It's a fully converged setup, small setup, so we have only 3 SSDs per server, I think 1 or 2 terabytes per SSD, plus the double of normal HDDs for the second and third copy of data. And yeah, the normal performance we get is this 200,000 IOPS and 2 gigabyte per second. More is not possible because we just have 2 times 10 gigabit on each server. So physically we are really filling the cables when we need the power, and it's really sometimes needed. What we did in the meanwhile is we are limiting the I/O on first on store pool level, and in the second layer on the KVM level. Why? If you provide performance, the performance will be taken by only 1 customer. That is always to have in mind. If you make a setup of something, think about what you want to give out to every user, to every virtual machine. So we are limiting per volume to 1 gigabyte per second I/O bandwidth, and around 50,000 IOPS, which suits to everything, just not the really big databases. So I said, what are we using StopOn now for? High available servers. Why high available? High available means the service does not go down. High available for me for a single server means if a node crashes, OpenNebula can step in because it recognizes the node goes down. It fires up the same virtual machine on another node. So the downtime of a server is 30 seconds, 1 minute, for example. That means this combination of shared storage based on store pool and OpenNebula with all this, the feature set it provides, we can guarantee really high availability even for single machines. Okay, for normal day-to-day use, we use live migration. For example, when we are patching the underlying nodes, we are migrating away all the virtual machines, and we don't need to agree with every customer on a change window because we need time slots for taking down the machines. And the last use case I just said is really about scalable databases and file servers. So where we really need performance, but also scalability in terms of volume. So resizing volumes in without downtimes and so on. So I think that gives a short overview about how the setup is. So we have the 2 locations inside 1 data center. The 3rd data center is not included here. We have a number of converged servers per fire zone. In the middle, we have a clustered Nebula setup. Also, if one front end goes down, the other one takes over. And we have then, besides the converged servers, which are providing these store pool clusters, we also have pure compute nodes, means nodes which don't have local storage and don't have are not taking part inside the cluster. So, and then we have the different environments which are then separated for each customer in VLANs with firewalls in between, etc. And I think these 30 minutes are done, mostly. what do we want to implement now? I'm so happy that you are talking now, Boyan. Said we have two separate clusters. What does it mean for us? We cannot copy or migrate a machine from one fire zone to the other one. What does it mean? If a fire zone goes down and we have an HR server, a single point of failure in one fire zone, it's down, it's away. So with the upcoming features, we can even use that in this setup. So we have a kind of inter-cluster replication on storage level, and we can, using the same OpenNebula mechanism, we can provide the same service even more reliable than before. Then multi-use volumes, for example, which is also very important to us when we are, for example, if you deploy a Windows cluster, you need shared storage, which is, so you have a single volume which needs to be accessed by all the machines which are part of the cluster. So like you have in a storage area, in a classical storage area network. That is something we also want to use in the future. Okay, other things we are currently planning and are implementing are Docker environments, so container environments, where there are certain integrations going on with Nebula, which look very reasonable and usable. Using Kubernetes or Ranger or Docker machine for Docker or container management. Monitoring, yeah, we are monitoring servers, but we have an anti-pattern in our environment because we are using a cloud environment, so fire up a machine and take it down, but we are using a centralized monitoring system that does not fit together. Because sometimes when you fire up machines, you cannot sit all day on the server and configure a central monitoring system. So what we need to do is, for example, do an automatic provisioning inside a monitoring system. And the next step then is also via a customer self-service portal to implement this kind of EBS storage Amazon provides. So a customer needs a terabyte of storage and he fires it up, takes it down, whatever, in a very dynamic way. And this should be also integrated into the OpenNebula environment so that a customer can use Sunstone. I need now on that three, so it's something we will check in the near future. I need on that 3 servers, I need a kind of shared storage, or I need a terabyte volume on that 3 servers. That is something which will be done in the near future. And last but not least, because we are hosted now today with StopOn, using also the iSCSI implementation. I said something I should not, which I was not allowed to say. Okay, good. Yeah, that was my 30-minute words about Nebula and StopOn. I'm very thankful to be here, especially to you and Maria, who has organized everything. It was a pleasure. Thank you. So if somebody has questions about special implementation details, we can talk afterwards. Because I know when we started using OpenNebula, I think it was still a 2-point whatever version. It costed us nights. Yes, and yeah, only nights and weekends. And I know there are a lot of people, and I see it also on the mailing list, where a lot of questions coming up when you are starting with such an implementation. So just in case, ask, and I'll try to answer. Question was, why did we use OpenNebula? I'm a friend first of open source. And OpenNebula at that time was the most promising tool to manage a cloud-based environment. So we took a look at Cloud Stack, we took a look at other tools, and OpenNebula at that time from how it was implemented was very easy to use, and so we got very fast results. We also took a look at OpenStack, for example. So with OpenNebula, we got such a learning curve. With OpenStack, we stopped at a certain point because it was practically not usable when you have not 5 people who are working with it every day. And Nebula was wirklich easiness. It was the possibility to change it as we need it to fit into our environment. Yeah, that was the main reasons at that time. Why did we choose StopOn? First, I don't like legacy storage systems, so it's normal. No, it was really the really fast answers on emails. So I felt even as a small customer, I said, okay, they are really taking care of you, and it became a matter of trust over time. So it is not only they are selling you something and telling you things you don't want to hear, but giving you real examples of how can you integrate the store pool into your environment. And what I said when we came here for the installation, it was clear to me that's our system for the future. And then I have seen what our hardware was able to provide as a performance. I've not seen it before. That with a single core on a server, you can create such a performance. I've learned a lot at that time. That it is even very important in which PCI slot to put a network card and a RAID card to get out the best performance. So which can kill the performance by 50% in a single server if you do it in the wrong way. So that was really impressive. I said that's a way to go. And the other, let's say the final drop was the OpenNebula integration. Any other questions? Then I hand over to you, Bojan. Because it's clustered. So we have a failover cluster. I understood that Bojan was asking why we have only one OpenNebula instance. Because we have a failover cluster. If one side goes down, the other side takes over, and every redundant system we have in place is split over the 2 fire zones. So we have a 40 gigabit network between them, and we have no issues from the performance point of view. It's only for reliability and availability that we are distributing over the 2 fire zones. And we had the case 2 years ago, when there was a flash, so a thunder went into the data center, and on the roof there was some air conditioning. So the fire workers arrived. It was a little bit not really burning. It was a little bit hot, but and there was no issue. But the fire workers said switch off the power, the electrical power, and so one building with I think 3,000 square meters of data center went down, but we had no service outage at that time. So that was really luck. It was not a problem in the data center just because somebody said switch off the power. And if they come and they say it, you are obliged to switch it off. thanks God.
I have one question. Have you experienced need for commercial support for OpenNebula, and are there critical situations where you can't handle yourself?
The question was if I see the need for commercial support from OpenNebula. Yes, I see it. So when we are growing more and more now, currently we are managing with Nebula around 500 machines. If it becomes more critical, for example, federations to different data centers, I think I would take the service, because then the setup becomes so complex that probably you're not able to manage everything anymore. Or another option for us is, I asked it just to Javier during the break, when you need special features, for example, funding a feature, that is something which is, I think, a good idea to do. So yes, there may be situations when you need this support, especially when you are not so deep inside OpenNebula. Like we are doing it now since 6 years, so we know it very good. Not everything, but mostly we know how it works, how it deploys virtual machines, what can we optimize. So we don't have the need yet. But for example, for a lot also of our customers, I think it's vital to use such a service. Please.